Welcome back. Let's do question 10. In the diagram, A, C, and D lie on the circle with center O. We can see A, C, and D, AE and DE. We have AE and DE are tangents to the circle at A and D respectively. They are tangents. So what should we think of here? We should think of the tangent theorems. Right, we have the tan chord theorem. Can we have tan chord theorem here? I don't see any. Right, we have the tangent chord CD, but CD is not subtending any angle. We have tangent there and chord CA, but CA is not subtending any angle. Let's also think of the tangents from a common point. Yes, we have the tangent from the common point, meaning that AE is equal to DE there. Right, what else? Also tangent with radius. Tangent is perpendicular to radius. Right, so it means angle A1 is 90 degrees and the angle D3 is 90 degrees. Okay, right, what else? And then we're given that angle ACD is 68 degrees, so this angle is 68 degrees, and then we have angle at the center here, right? So an angle at the center is 2 times angle at the circumference. Or let me say angle subtended by a chord at the center is equal to 2 times the angle subtended by the same chord at the circumference, meaning that angle O2 is 136 degrees. Okay, let's look at the question. The first one, prove that AODE is a cyclic quad. AODE, let's try to see if this is a cyclic quad. How do we prove that a quadrilateral is a cyclic quad? One, you have to check if there are any interior opposite angles that add up to 180 degrees, which are supplementary. And we have here this and this. 90 plus 90, that's 180. So this is a cyclic quad, right? Also check for the exterior angle of a cyclic quad, like this one. You see, angle D1 and angle A1. Okay, they are equal. And also check for the angles in the same segment, right? If you have angles that are subtended by the same chord and they are equal, you can also use that to prove if a quadrilateral is a cyclic quad. Okay, right. So we have an idea here. Let's answer our question. So we're saying that angle A1 is 90 degrees. So angle A1 is equal to 90 degrees, and then reason tangent perpendicular to radius. Right, we have angle D3 also. Angle D3 is equal to 90 degrees, again tangent perpendicular to radius. Okay, and then these two angles are supplementary, therefore AODE is a cyclic quad. And then the reason you say opposite angles supplementary. Question B, determine angle E. Right, I've put the dotted circle here because we proved that AODE is a cyclic quad, and then we say this angle is 136 degrees. Okay, because this one is 68 degrees, this one is 90, this one is 90. We want to find this angle. Remember, we just proved that AODE is a cyclic quad, isn't it? So we have angle O2 is equal to 136 degrees. Why? Because angle at center equals 2 times angle at the circumference. And then now we want to find angle E. We can say angle E, therefore angle E is equal to 180 degrees minus 136 degrees. And then these are opposite angles of a cyclic quad. So angle E is equal to 44 degrees. Okay.